In level 4, we will be solving optimization problems in the calculator using the distance formula. We've seen this before, but we want to find the shortest distance from a point to a curve. So the graph of f of x equals x squared plus 6x plus 9 looks something like this. It has its x-intercept at -3, and it's a parabola. I know this because if I put this in factored form, it's x plus 3 times x plus 3, or x plus 3 squared. So it has its root, or its x-intercept, when x equals -3. It only has one x-intercept. I could also figure out what the graph looks like by graphing it in my calculator. And I want to find the shortest distance from the point 3, 6, which maybe is somewhere over here, to this curve. So what I'm going to do is call this unknown point on the graph x comma y, some xy pair. And I want to use the distance formula to write a function for the distance from the point on the graph to the point 3, 6. But if I'm going to plug this in my calculator to do an optimization problem, I don't want to have two variables. So instead of y, I need an expression for y in terms of x. And I can just use the function x squared plus 6x plus 9. This is like y equals x squared plus 6x plus 9. So for any x coordinate, the corresponding y coordinate is whatever you get when you plug it into the formula x squared plus 6x plus 9. So that's what I'm going to use as my xy pair. X is just x, but y is going to be the actual function from the graph, from the parabola. And I'm going to plug this into the distance formula. So I subtract the x's, and I get x minus 3, quantity squared, plus, and then I subtract the y's. My y coordinate for my unknown point, I use x squared plus 6x plus 9. That represents the y coordinate. It's an expression for y in terms of x. And then I subtract the y coordinate from the point that I'm given, so minus 6. And square it. And then the calculator doesn't care if you simplify it, but you can if you want. This would be x minus 3 squared plus x squared, oh, that should have been 6x, plus 6x plus 3. So plug that into your calculator, take a look at the graph, and you get a weird graph that kind of looks like this. And this function represents the distance from the point 3, 6 to any point on the graph of that parabola. And if we want the shortest distance, we want to find the minimum point on this graph. So use your calculator to find the minimum. On your calculator, press second and then trace, and then choose min for minimum, and it will say left bound question mark. Move the little spider guy over to the left of the minimum point, press enter. Then it will say right bound question mark. Move the little spider over to the other side, to the right of the minimum point, press enter. And then when it says guess, you can just press enter again, and it should find that minimum point, which is the point -0.419, 3.482. Now, the x-coordinate of this point represents the x-coordinate on the parabola, and since this function represents distance, the y-coordinate represents the shortest distance. So the shortest distance would be 3.482 units. Now, you might also be asked to find the coordinates of the point that's closest to the graph. If you have to actually find the coordinates of the xy pair, these coordinates up here, you are given the x coordinate when you find the minimum point of your distance formula. So, coordinates of the closest point. The x-coordinate is the x-coordinate that we were given when we found the minimum, so negative 0.419. But to find the y-coordinate of the closest point, when you know an x and you want to find the y that goes with it, you plug that x back into the original equation of the parabola. So the parabola was f of x equals x squared plus 6x plus 9. So the y-coordinate of that point is going to be f of negative 0.419. Plugging that in, negative 0.419 squared plus 6 times negative 0.419 plus 9, we get 6.310. So that would be the coordinates on the point of the parabola that is closest to the point 3, 6.